Welcome to lesson 8.1, the midpoint and distance formula. Now, I will say this, the midpoint and distance formula are two formulas you got to know for this unit. But more importantly, you have to know how to use them, okay, and when to apply them. Because you could do some cool stuff with this. So it's not just about knowing the formula, it's knowing when to apply them. So without further ado, let's get into it. We're going to start ourselves off with the midpoint formula, all right? Now, I'm not going to give you the formula just yet. I'm just going to explain how the midpoint formula works. Now, if I have AB right here and I want to find the midpoint, what you do to find that midpoint is basically you just take the average of the 2 points, all right? And what I mean by this is, first you write down your points. So this point is 0, 2, and this point is 8, 8, okay? So those are my 2 points. To find the midpoint, I'm going to average the x and y. So what I mean is, if you look at your x coordinates, you have 0, and you have 8, so we're going to average those together. So 0 plus 8 divided by 2. And you can average your y coordinates. That's 2 and 8, so you're going to average your y coordinates. When you find the average, do 0 plus 8 is 8, divided by 2 is 4, so that's the average of my x coordinates. 2 plus 8 is 5, divided by 2 is 5. All right? So 5 is the average of my y coordinates. So the midpoint will be at 4, 5. All right, so that if you go to 4, 5, let's do that. 4, 5 is right here. And sure enough, that looks like that is right in the middle. Remember, the midpoint is right in the middle. And that would also make those two parts congruent, right? Okay, so that's basically what the midpoint formula is. It's just averaging the x coordinates and averaging the y. Nice and simple, right? You got that. So I'll give you the formal version of this, of this formula, okay? The formal version is the midpoint formula is capital M, because small m means slope, is equal to x1 plus x2 divided by 2, comma, that's a comma right there, y1 plus y2 divided by 2. That's just what the midpoint formula is. So for this first question, it says find the coordinate of the midpoint of mn with the endpoints of m and n. Okay, so that's the endpoints of my line. I want to find the midpoint of it. So what we would do is just step 1, we'd rewrite our formula, which happens to be right here for us. Step 2, let's just plug in, okay? So to plug in, I would write m is equal to x1 plus y1, which is 1 plus 7 divided by 2, comma, y1 plus y2 is 2 plus 9 divided by 2. All right? That will be my midpoint. And if you're wondering where those numbers come from, that's xy, x1, y1, and this is x2, y2. Remember, superstar students are going to label those every time. So we'll start simplifying now. My midpoint will be equal to 8 over 2, comma, 11 over 2. And then we're going to fully divide this. My midpoint is equal to 8 divided by 2 is 4. And right now, some people are freaking out. They're like, 11 divided by 2, that doesn't go in. Well, that's fine. It's a decimal. It's just 5.5. So my midpoint is at 4, 5.5, and that we're cool with that. We are cool with a decimal in this, okay? We are adults. We can handle that, okay? And let's just graph it to check it out, because that's just good practice, right? It's good to just show your work here so we can see what we're talking about. So if my points are 1, 2, that's my point M, and N is 7, 9, which is right here. That's my N. Let's connect it, all right? And let's see if the midpoint is, in fact, at 4, 5.5. So I'm going to go to 4, 5.5, which is right about here, right? That's 5.5. That's 4. And sure enough, that looks like it's right in the middle. That is my midpoint. Nicely done, us. So that's a pretty straightforward application, okay? Find the midpoint of these 2 points. But that's usually not how we're going to use the midpoint formula. We have to know how to apply it to different kinds of problems. And I'm just going to give you one example. But one thing you should always be asking yourself is, what formula do I need to solve this question? All right, so for this guy right here, this is a little bit different. Let's take a look, okay? It says the endpoints of the diameter of a circle are -3, 4, and 5, 6. And I'm just going to graph those out. -3, 4, and 5, -6. All right? That's the diameter circle. Find the center of the circle. Now, before I do this, let's actually just draw a rough draft here. This is the diameter of a circle, right? That's a terrible, terrible line. I'm going to try to do that a little bit better. Okay? You know what? Since that's the diameter, let's actually complete the whole circle. It looks something like this. That's also a terrible circle, but it'll do for now. Now to find the center, I would have to just find the midpoint of this diameter. See? So this is really a question asking for the midpoint. The center is going to be the midpoint of the diameter. So this is really a midpoint question. And that's the skill that you need to know here. It's like, when do I use which formulas? So in this case, I'm using the midpoint formula. All right? And now that I know I have to find the midpoint, let's just find the midpoint of the diameter. So first thing, we use capital M. Remember, because capital M means midpoint, lowercase m means slope. We're going to write our formula out because we're good students. x1 plus x2 divided by 2, comma, y1 plus y2 over 2. That's going to get us our point. So we're just going to plug in. This is x1, y1, x2, y2. So we get -3 plus 5 over 2, comma, 4 plus -6. Let's put that in parentheses so we don't mess anything up, over 2. Now our midpoint will be -3 plus 5 is 2 over 2, comma, 4 plus -6 is -2 over 2. And finally, we're going to divide. We get 1, -1 as our midpoint. Now let's check here. Let's go to 1, -1. Now, does this look like the center of this circle right here? Does that look like the center? Sure does to me. So the center is at 1, -1. Okay? So, like I said, it's about figuring out when to use the formula. That's the big thing here. Next formula. We're going to be using the distance formula in this guy, okay? So we're going to find out how to find the distance between 2 points. Now, I'm going to offer a little explanation about how this formula works, just, for those who are interested. The distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, some of you might be saying like, whoa, that's a lot. But what this formula is actually doing is it's actually just the Pythagorean theorem in disguise. This is the same thing as c squared is equal to a squared plus b squared. All right, you might see this is the a right here, this is the b right here. All right, see how it looks similar there? Now, why would these two formulas look similar? And like I said, you don't have to understand this, it's just good to know for people interested in the mathematics. Well, what you do for the distance formula is you're actually just creating a right triangle, which you can do for any 2 points on the coordinate plane. See how I just created a right triangle? If you just go down and over, you get a right triangle. And this AB, that's just finding C. So what you actually are doing is finding the distance of this and the distance of this. So that's A, that's B, and just plugging into the formula. So this is just a fancy way of doing the Pythagorean theorem. But you know what? That's too complicated for some people. If you're just like, what's that all about? Just know how to use the formula, okay? So to find the distance between A and B, what you would do is this. You'd write down your 2 coordinates, 0, 2, and this is 9, 8. Okay? So when we do this formula, let's just get into it. So our distance is equal to the square root of, we've already written down our formula, x1, which is 0, minus x2 squared, plus it's x2 minus x1. It makes no difference as long as you go in the right order. So, and that's x1 minus x2. So we're going to do y1 minus y2. Okay? So the distance is going to be equal to, let's do this, 9. 0 minus 9 is -9 squared, plus 2 minus 8 is -6 squared. We're going to keep plugging in, so we get the square root of 81. -9 squared is positive 81. These will always be positive when you square them. Plus 6 squared is 36. And the distance is going to be equal to, that is 117 square root. Now, you'll say like, whoa, that's not a whole number. That's fine. We're cool with that. We could just leave it as this. Now, sometimes it might say nearest 10th, but for now, if it's not asking us for anything extra, that is just our answer, okay? So it's just about memorizing this formula and plugging in. let's try another example of this, okay? We're going to try another example. This question's a little different, all right? And let's see if you can notice how it's a little different. But this says, what is the length of the line segment whose endpoints are negative 2, 4, and 5, 1? So this one's asking us for the length. If it says length, that is the same thing as the distance. So let's put a note there, the same as distance. To find the length of something, it's the same as finding the distance between 2 points, okay? So if we're looking for the length, we know it's the distance formula. So what we're going to do is write out our distance formula. Distance is equal to the square root, and please include the square root, x2 minus x1 squared plus y2 minus y1 squared. All right, we got our points, x1, y1, x2, y2. And let's start plugging in, okay? x2 is 5, so it's 5 minus negative 2 squared. Keep in mind how I'm watching my negatives there. Plus 1 minus 4 squared. My distance is going to be equal to 5 minus negative 2 is 7 squared, plus 1 minus 4 is going to be equal to negative 3 squared. Keeping my negatives in those parentheses. The distance is going to be equal to 49 plus 9. And so we get, as a radical, if you add that together, you get the square root of 58. Now, that's one thing, but let's also convert this to a decimal, to the nearest tenth. So it could ask us that. So to just do this in the calculator, if we put square root of 58 in the calculator, square root of 58, we get 7.61. To the nearest tenth, we're just going to round that to 7.6. All right. Now, for our final problem here, we're going to do an application problem again, okay? Now, obviously, this has to do with the distance, but let's just get into this, okay? So rectangle GHIJ has these points. Find the length of the diagonals of the rectangle. Now, remember, when I see the word length and I'm given coordinates, I know that this is the distance, all right? So I'm finding the distance of the diagonals. So let's figure out what our diagonals are. So let's start by just graphing this. So G is 1, 1, H is 5, 3. And by the way, I suggest pausing the video and doing this on your own if you can, but we'll do it together. I is 4, 5, and J is 0, 3. All right, so this is our rectangle, okay? So G, H, I, J. So now we got to find the length, the length of the diagonals. So that would be either GI or JH. So it's either GI or JH. Now, to find the length of the diagonals, all we're going to do is use the distance formula. Now, you might remember this property, but the length diagonals of a rectangle are congruent. So it doesn't matter which one we find, right? We just have to find one of them. So let's find the length of one of our diagonals. Let's use GI. So this can be our x1, y1, x2, y2. Now, we're good students, so we're once again going to write out our formula. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Distance is equal to, let's plug this in, 1 minus 4, 4, geez. Okay, let's do this right, okay? It does matter, okay? x2 is 4 minus 1 squared plus 5 minus 1 squared, okay? The distance is now equal to 4 minus 1 is 3 squared plus 5 minus 1 is 4 squared. The distance is equal to, don't forget the square root of 9 plus 16. And so the square root is equal to the square root of 25, which actually just goes down to 5. So that's a nice clean number, okay? Now, decimal to the nearest tenth, well, we don't need it because we already have this, so it's just 5. Now, the clear thing here was this. To figure out this problem, it was no problem to figure out, okay, let's use the distance formula, plug in. But the key thing here is to know that when the word says length, you know that you're using the distance formula. Find the length of something, you're going to use the distance formula. Okay, so if you're given coordinates and it says length, find the distance formula. All right, guys, that's it for this lesson. Remember, the formulas are easy. Knowing when to apply them is the hard part. All right, guys, so my advice for today is don't eat rocks. You'll crack your teeth on them. True story.